Hello and welcome to GrossiMath.com, where math is for everyone. Our journey continues on the Solving Equations playlist. So what we're going to do right now is we're going to learn something called an equivalent expression. Okay, and the purpose of this is not so that we can go deep into math theory. The purpose of this is to teach us a cool trick that we can do with our terms. So in math, there might be a fancy sentence like this one. An expression with the identical terms are equivalent. Okay, so expressions with identical terms are equivalent. Okay, but what does that really mean? Well, for us, it means that we have a cool little superpower that we can use to help us with solving our algebra equations. So we've been learning about terms, and here it is in terms of terms, haha. Okay, here it is in plain English. You can move terms around. You can move terms around as long as you don't mess up the signs. Look at this example. Look at this expression right here on this particular expression that I'm showing right here. Okay, remember an expression is a group of terms, right? So there are two terms in this expression. There's a negative y term and there's a 3x term. But in our last video, we learned that this 3 is technically a positive 3. This is the lead term, so therefore this plus sign is only implied. But now let's look at this expression. It also has a negative y, and look, it also has positive 3x. And guess what? Those terms are what they call, those expressions, these two expressions, this one and this one, are what they call equivalent. Equivalent means equal. Okay, and you can kind of see the word equal kind of started there. So right here, I see my same two terms. Positive 3x was in the front, but now positive 3x is in the back. Negative y was in the back, but now negative y is in the front. Okay, so let's try to mess with this superpower and see what we can do. Okay, so this says create an equivalent expression. Ooh, it sounds very complicated, doesn't it? But we know that an expression is just a group of terms. And we also know that equivalent expression is just an expression that basically is the same, is equal. So let's do that. All right, so here I go. First, I'm going to identify my terms. This is the skill we learned in video number 1. Second, I check my lead term to make sure it has a sign. This one is negative. If it's negative, we can leave it alone because we don't need it implied positive. It already has a negative, so we're fine. Okay. So how can I make an equivalent expression? Well, this has 3 terms, 1, 2, 3. So the easiest way for me to make an equivalent expression is to make 3 terms. And just move them around. Now, there's more than one correct answer, okay? So let's say that I take this negative 3 and I move it to the back. Okay. Well, as long as I keep it as a negative 3, I'm allowed to do that. That's the purpose of this video, for you to understand. You're allowed to change the order. Okay, so this one I moved. Now let's do this one, negative 2x. Let's put that one in the middle. Okay, so that one I moved. Now let's do this one, positive x squared. Okay, now don't mess up the sign. Positive x squared. Now I made a little mistake on purpose. Does anyone know what it is? I should not have written this plus sign. Do you know why? Because this x squared just became the lead term. And remember, if it's the lead term, we're allowed to leave the plus sign as an implied plus sign. We know that it is there, but we do not have to write it. It's just invisible or implied. Okay, so here it was visible, or what they call explicit. Explicit means that it's visible. It was visible because this was not the lead term. This was just the middle term. But when I moved it to the front, it became the lead term. And since it became the lead term, it has superpowers to have its plus sign become implied. Okay. The plus sign is still there. We just don't see it. Let's try this again. Okay, let's try one with kind of an ugly term that we haven't seen in a little while since video number 1. All right, let's do this. I see the minus sign. Remember, exponents don't mess with terms. Fractions don't mess with terms. That's why we're learning it this way, so that you don't have to feel the intimidation of all the weird stuff that pops up in math. Now this minus sign signifies a new term begins. But look, I see another minus sign now. Be careful. It's in parentheses, so it doesn't count. Someone's going to say, well, that's a really big term. Look how small those ones are. It's okay. That's allowed. You can have a big term. 1, 2, 3. Nobody said there's a rule against big terms, right? So don't hate on him just because he's big. Okay, so now let's move our terms around. Okay, so let's move this one first. Let's see. Let's move the big one first. Okay, let's be brave here. We'll put our negative 8r parentheses r minus 1. I'm literally copying, guys. I'm not doing anything at all mathematical except moving the terms around, which is technically mathematical. But the rest I'm just copying. Okay, so this term I now moved. Which term should we do next? Let's save the fraction for last. Let's do this 2r squared. Remember, squared is another word for the exponent 2. Okay, so this is 2r squared. Do I just write it like this? No, this is impossible because look, how would I know that this new term is starting? I need a plus or a minus to start a new term. So what should I put there? I should put a plus. Who knows where I came up with this plus sign? How did I know to put a plus sign? Well, because this was the lead term. And what does the lead term have if this number is positive? It has an implied plus sign. So when it moves away from being the lead term and became the second term, guess what? The implied plus sign became visible. Another word for visible is explicit. So this plus sign went from being implied to being explicit. Okay. So now this term has moved. I'm not done yet. I still have one more term to go. Minus 1/2. Minus 1/2. I'll bet you thought I was going to say you had to do something special because it's a fraction. Nope. This expression is exactly equivalent to this expression. So if I input a 10 for these r's and I input a 10 for these r's, because they're equivalent, I would get the same output. And that's very powerful in algebra. We like that. Okay, so we're allowed to move terms around as long as we don't mess up the signs. Okay, so that's the end of this video. I hope you guys learned something today and enjoyed it. Thanks for watching. Don't forget to like and subscribe and to click the bell icon, and also to visit the website where math is for everyone, www.grossimath.com.